People long dreamed of creating these extreme machines. Now, humanoid robots are here. They think like we do, move like we do, and even sacrifice themselves for us.
We want our robot to change society, because robots must be useful.
Electronics and computing, progress in vision systems, there's many pieces of it. We will see much more capability continue to grow.
Since the Industrial Revolution, people have entrusted some jobs to machines. But there may come a day when humanoid robots do much more complex jobs. Then, what will people do?
And you'll see more and more robots doing things in society, whether it's manufacturing or service applications or home healthcare applications.
The key will be to skillfully dividing labor between humans and humanoid robots.
The disaster that hit Japan in March 2011 accelerated efforts to develop robots with human traits. The Fukushima nuclear accident left people powerless. Robots can take over when things become dangerous. They can plow through rubble, climb ladders, even make repairs. People are turning to humanoid robots to handle all of these tasks.
We're eager to launch it soon to end the crisis.
By joining forces, we can make a truly useful contribution. Only a humanoid could do it.
The day will come when robots will really assist mankind.
The nuclear disaster in Japan sparked explosive advances in humanoids at the front line of robotics development. This program explores the future that's fast approaching. Asimo was created by Honda's research and development subsidiary. We were allowed to film their top-secret robotics laboratory. Japan is a worldwide leader in the development of humanoid robots. Asimo is the country's crowning achievement. Engineers continue to make improvements. Asimo's most innovative feature is its advanced intelligence. The robot can think and act on its own without human intervention. That's made possible by sensors that replicate our 5 senses. Asimo's head contains 8 microphones. It uses them to listen and engage in conversation. 2 cameras work as eyes. They can detect humans and use stored data to identify them.
A facial recognition problem.
I don't think so.
Please cover your face.
Asimo's artificial intelligence analyzes a vast array of information. That's how it understands people's requests and takes appropriate actions. Asimo also has a sophisticated sense of touch. Its fingers can make subtle movements, like a person's. Sensors are embedded in the fingertips, too. They can gauge the hardness of an object, like human fingers do. Most robots use a fixed amount of strength to grab things. But Asimo exerts more power to open a tightly sealed water bottle and less when holding a paper cup. Its artificial intelligence uses information from the fingertip sensors to adjust the grip. The developer's ultimate goal is for Asimo to be a valuable partner that coexists with humans. The engineers who created Asimo all grew up watching animated shows about robots, such as Astro Boy, Doraemon, and Gundam. They dreamed of someday making their own. Satoshi Shigemi is the development team's leader. He has been designing robots for the past 16 years.
From the beginning, we wanted to design a robot that could help people. To realize that dream, we're constantly asking ourselves, what kind of robot would be able to change society, make people happy, and make life easier for people around the world? Our idea is to create a robot that will change how people live. We're working through the technological issues, one by one, in order to reach that goal.
Asimo's advanced physical capabilities are revolutionary. The robot can walk and run. It can reach speeds of up to 9 kilometers an hour. For robots, walking is much easier than running. When running, both feet momentarily leave the ground. Balancing in midair is no easy task.
Maintaining posture while jumping or floating in the air was a major technological breakthrough. Asimo leans its upper body slightly forward to maintain overall balance. It goes forward straight in the air.
Sensors in Asimo's waist measure the robot's angle. It leans slightly to compensate, forward or back, side to side. That's how it stays perfectly balanced in the air. Asimo has been evolving ever since development began in 1986, much like a growing child. But something happened that made researchers realize Asimo's real-world limitations. It was the accident at Tokyo Electric Power Company's Fukushima Daiichi nuclear plant. The damaged reactors released radioactive substances, making it difficult for humans to deal with the crisis. People needed something that could confront the dangers and bring the plant. But Asimo wasn't up to the task. It could move nimbly over an office floor and other flat surfaces, But large vertical gaps and obstacles were a different story.
We heard from many customers. We ourselves regretted that Asimo couldn't be of help. It was obvious that Asimo we had built wasn't ready for real-life action. We realized right away that we needed to make something different, something new that could offer immediate assistance.
Honda wasted no time. Company officials offered to create a robot free of charge to assist TEPCO in the recovery. TEPCO accepted. Officials asked for a robot that could open or close valves inside the nuclear plant.
We wanted to flush out radioactive materials that remained inside the pipes and bring down radiation levels in the facility. That was our first goal. Unless we opened or closed the valves, the area would remain highly radioactive, and that would prevent workers from entering the facility and impact the entire decommissioning schedule.
How many valves are there?
Each unit has from several thousand to tens of thousands of them.
In July 2011, 4 months after the accident, Honda began designing a robot for use at the nuclear plant. Members of the Asimo team were put in charge of the project. A humanoid robot would take too long to build, so engineers focused on making a robot specifically for operating valves. Asimo was crucial to their efforts. Its ankles employ advanced balancing technology. Developers reasoned that using it would allow the new robot to work inside rubble-filled reactor buildings. The team worked exceptionally fast, completing a prototype in just 4 months. They turned Asimo's leg into an arm for operating the valves. Even when the base moves, the arm remains steady. So far, so good. Officials from TEPCO evaluated the prototype at the National Institute of Advanced Industrial Science and Technology. The government-backed group for cutting-edge research contributed to the development effort. A TEPCO official couldn't take his eyes off the robot's movements.
We may be quite demanding.
That's okay.
We might be quite direct.
The test is designed to replicate conditions inside the nuclear plant. The robotic arm is remote controlled. Testers send the arm toward one of the valves. There are a number of unknowns, including the condition of the valves. They may have rusted since the accident. A valve might break if the robot applies too much force, or it might not budge at all. The robot uses just the right amount of force and turns the valve on the first try. It's passed the test. This robot can do more than inspections. It could help in the recovery effort.
From what we've seen, the robot seems near perfect. We want to use it as soon as the need arises. It's important that we quickly do what we can to make that possible.
The Fukushima accident also encouraged U.S. developers to design emergency response robots. Department of Defense officials have spearheaded the effort. Before, they had shown little interest in humanoid robots. Now, they view them as vital for disaster response. The architect of the new strategy is Gil Pratt of Darpa. He oversees funding for leading-edge research at the Department of Defense.
There are many aspects of disaster response in Fukushima that inspire people in robotics to work on new capabilities. If they were able to take action during those first 24 hours, then the first reactor maybe would not have blown up in an environment that is too dangerous for a person to do. And what's important to us is that the robot is compatible with human environments, compatible with human tools, and also is compatible with human operators without special training. As a result of that, the easiest form that comes to mind is the human form.
DARPA is backing the development of a humanoid robot for catastrophes, such as nuclear power plant accidents. This company is leading the development work. It has already built several military robots.
Okay, I'll show you the current status of the robot.
This is the first American-made humanoid robot for disaster response. It's called Atlas. Before, U.S. designers had focused on robots with specialized functions. Why the sudden interest in humanoid robots? Traveling over debris, prying open valves, using tools for repairs. Performing multiple tasks like these is impossible for specialized robots. Crises also require robots that can navigate doors and stairs. Humanoid robots are ideally suited for such situations. Tests of this prototype were going smoothly. It can easily climb stairs and jump from a height of nearly 1 meter. It can negotiate obstacles using its arms and legs. It can already handle more demanding environments than Osimo can. Atlas is loaded with technologies originally designed for military robots. A quadruped robot called Cheetah can race through a battlefield at 50 kilometers an hour. LS-3 is for transport. It can carry heavy supplies for soldiers. The ferocious-looking robot gets its strength from a powerful hydraulic drive system. A hydraulic device can be small, yet quite strong. The black cables convey hydraulic power to the legs. That generates the brute force required for harsh conditions on the battlefield. A web of hydraulic cables covers Atlas's body. They form a muscular suit of armor for clearing debris. Another important technology comes from military robot engineering. This machine's joints have a wide range of motion. They allow for flexibility that humans can't achieve. Atlas's joints are capable of moving in 28 different ways. Atlas can crawl through narrow spaces and withstand sudden shocks.
But then we have the knee. This has 3 in the hip, just like us. This way, and then this way.
I am very impressed with the number of degrees of freedom. It will be able to do these human-compatible tasks without a lot of the limitations that other robots have.
Engineers will combine Atlas's rugged body with sophisticated artificial intelligence that's almost near completion. They aim to complete the robot by December of next year.
One reason you see humanoid robots is because there's some people working who are really interested in robots as an entertainment thing or as a performance thing. I think that's different. We're much more interested in basic capabilities for emergency response, rescue.
He came to invite engineers to join a project sponsored by the U.S. Defense Department.
Okay, March 11th. After 24 hours, if only a robot had been there to go and open that valve, the entire disaster could have been averted. But we didn't have one. And furthermore, we didn't have anyone that could do the job. So shortly afterwards, we actually started planning the Darpa Robotics Challenge.
Researchers hesitated to throw their hats into the ring.
So actually, to me, it's difficult to not to see that some of the results of DRC gonna be served to advance, as you say, advanced military technology.
The DRC is about developing robots that I believe wholeheartedly are completely impractical for military purposes, for offensive military purposes. Will the technology that we come up with find its way into military systems? Probably yes. But I guarantee you that if you work on a robot for healthcare, there's a chance that that technology will also find its way into military systems.
The members of one Japanese research institution wanted to take part in the competition. They worked at the University of Tokyo's robotics lab. Researchers there, along with those at Honda, are global leaders in robotics engineering. But they faced a major obstacle to competing. The university bans military-funded research. Three researchers made a decision. They told the university they were leaving. Then, they decided to set up a venture company and enter the Darpa Robotics Challenge. They couldn't shake the feeling that they should leave their quiet university lab The strong force comes from a large electric current that pushes the motors to their maximum limits. A reddish fluid circulates through the robot's body. The fluid serves as a coolant that keeps the motors from overheating. The cooling system should enable the robot to perform hours of grueling work at disaster sites. The time has now come for the developers to apply their years of research to the real world.
A nuclear crisis has happened here in Japan. Radiation is escaping. Researchers in every field must wonder at least once if the technology they've been working on could help resolve the crisis. By joining forces, we can make a truly useful contribution. It's with this in mind that we decided to enter the competition.
One country is quickly catching up with Japan in humanoid robotics: South Korea. KAIST is a government-funded lab for the advancement of science and technology. Researchers there were among the first to express interest in Darpa's robotics challenge. This humanoid robot is called Hubo. It's modeled on Osimo, which Honda spent 14 years developing. Hubo was built in just 5 years. Hubo deftly manipulates its hands, and it's also good at dancing. Its moves look just like Osimo's. Hubo has been undergoing a major upgrade ahead of the competition. It can now bend backward at the waist while walking to handle all kinds of environments. It can quickly pick up tools. The tests were going well. People have always compared Hubo to Osimo. Engineers now had a strategy to get ahead of the Japanese developers. They decided to publish certain details about Hubo's design and pursue joint development with researchers at other institutions. One could say that this space inside Hubo's chest captures the heart of their thinking.
It's empty now, but this is where artificial intelligence will be installed. It's removable.
Hubo does not yet possess artificial intelligence. Its motions are as sophisticated as Osimo's, but Hubo's movements are all pre-programmed. U.S. universities that lead research into artificial intelligence will develop a brain for Hubo. The stage has been set for a joint U.S.-South Korean team to compete in the Darpa Robotics Challenge.
Sharing is the key to making technological advancements. That's true in South Korea and in other places too. Research shouldn't be confined to one place. People developing humanoid robots elsewhere are too close-minded.
Researchers at Honda were also invited to enter Darpa's competition. But they declined. Their energies were focused on designing a robot to tackle Japan's nuclear crisis. Nearly a year has passed since Honda's robotic arm passed evaluation tests, but the device has yet to be deployed to the nuclear disaster site. That's because officials at TEPCO requested a change in specifications. Engineers have replaced the valve-turning hand at the end of the arm with a camera. TEPCO had changed its plan. Officials decided to put priority on assessing conditions inside the plant's facilities. They said it was too early to have robots work on valves.
There wasn't even a recovery plan in place when we were working out the valve manipulation tasks. Confusion also prevailed at the site. We were expecting valve work to begin 2 to 3 years after the disaster. But the timing has ended up being later than what we'd assumed 1 month into the crisis.
The robotic arm will soon be sent to the accident site. It will provide the first images filmed from high up. The robotic arm was not the end of Honda's efforts. Its engineers had another secret mission. They would develop a new humanoid robot. It would be an updated version of Asimo for use in disasters. Place in January. Global manufacturers displayed their latest models. Companies are developing in a matter of 5 minutes. All that's required is step-by-step manual instruction. No complicated programming is needed.
Let's pick up this part. So you bring the arm to the part. Yep, just like that. So we have the part. Close the grasp. Yep. Grab the arm and bring it to the table.
And then I emailed them and talked to them and whatever.
Anyway, on that, it's fine. So you just pick, did a pick and a place. At this point, you're already able to do the task. So if you
I can move that over there.
It's going to look for the object. You can do this task back and forward, and you already built some common sense. You really need to grab back. So you'll be eventually possibilities for that. We can do it ourselves. Sure.
The expression of the face on the LCD screen shows whether or not the robot has understood the task. Baxter costs $22,000, a bargain for a humanoid robot. The maker says buyers can recoup their investment in several months and slash labor costs.
I'm very impressed with it. I work for a small manufacturing company, and we have some older employees who are looking to retire. And there's some tasks that Baxter could do for us very effectively.
Plus, it would be cheaper than employing a person. It's not going to get tired. It's not going to need to stop. It'll keep running while everybody else is taking their lunch.
The Boston-based manufacturer has a flood of back orders. Officials say someday Baxter will work at places like coffee shops, taking orders and grilling burgers. Eventually, they expect to have 500,000 U.S. customers.
Today we're focused on manufacturing, and there's a very big opportunity in manufacturing. But there's lots of other places that a robot like Baxter could go. We had the Industrial Revolution at the turn of the last century. We've just gone through the computer revolution, effectively at the turn of the most recent end of the century. We're now into the robot revolution.
Will people and robots someday compete for jobs? At 8:30 one morning, a group of new employees takes part in daily morning exercises. They are 13 humanoid workers called Next Stage. This company began using the robots in earnest last year. They have 2 eyes and are just like humans. They're cute. This factory manufactures money sorting machines for cash registers. The humanoids work on a production line that was previously manned entirely by humans. The robot visually confirms the parts set in place by a human worker. Then it begins its task. It adjusts itself to the speed of humans. Next Stage can also handle other tasks, such as fastening screws and installing rubber parts. The 2-armed robot is already managing jobs that just 6 months ago had routinely been assigned to experienced staff. The robots have taken over for 13 workers so far. Officials plan to reassign those workers to more sophisticated tasks. They say that will boost productivity overall. The robot next to me is doing a more precise job than I do. That helps me stay more focused on my work. Thanks to the robots, we can afford to spend time polishing skills and techniques that only humans can master. I want to do a better job than they do. Humanoid robots don't demand breaks or higher pay. Once they become even more advanced, how many jobs will be left for humans? The development of a new humanoid based on Asimo was progressing by leaps and bounds. The envisioned setting has switched from a peaceful lab to a warlike disaster zone. The engineers had completed a prototype. The president of Honda R&D came to have a look. As the robot walks, an engineer pushes it from the side. In a real disaster, robots would be subjected to surprise impacts.
Can it stay planted?
As much as it can before stepping aside.
One of Asimo's weaknesses was that it could only walk on a smooth indoor surface. Engineers made quick modifications for disaster sites. Now the robot can travel over gaps and uneven surfaces. A new test course mimics a disaster site. Engineers will test the prototype's motor skills and judgment on this unfamiliar proving ground.
The robot will pause here.
No, that would be pointless. Disaster has actually occurred in Japan, so we should be realistic when talking about it. Otherwise, we can't really save people or make ourselves useful. We must have a firm foundation on which to set clear goals for the robot. We don't want to make the mistake of creating a robot that promises a lot but proves useless in the real world. We want to make a disaster mitigation robot that limits damage and helps society. That's our goal.
The race to develop humanoid robots is heating up in other parts of the world. Scientists at this university are developing artificial intelligence for Hubo, the South Korean humanoid. Driving a vehicle is one of the challenges in Darpa's robotics competition. Engineers run an experiment with Hubo at the steering wheel.
Uh, 100%. I believe within the next 7 years, so before the year 2020, that you're going to see humanoids like Hubo doing a lot of the tasks like driving the vehicles, turning valves. This is not science fiction.
I am very hopeful that robotics will, and particularly the robotics that is coming from the Darpa Robotics Challenge, will have a great impact, and would like to make the world a better place so that we actually can have a functioning economy with a high quality of life in the decades to come.
Humanoid robots are the ultimate dream machines. How will the development of robots that think, move, and work like humans change our future? These robots may bring both happiness and despair. One thing is certain, humanoid robots will continue to develop and evolve. Next Stage was born in this factory. The robots now work with humans and contribute to people's lives. These robots are bound for an electronics parts factory in northeastern Japan. They will work on an assembly line side by side with 100 humans. This year, the manufacturer expects to sell more than 100 of the robots around Japan. The 21st century has been dubbed the century of the robot. The future has already begun.